I'm here to talk to you today a little bit about cross-platform gaming, what's difficult about it, what's important about it, and why everyone needs to pay attention to the issues that affect both developers as well as consumers in a cross-platform world. So before I get into that in a lot of detail, I'm going to tell you a little bit about Transgaming, if you haven't heard of us before. We're probably most well known right now for our Cider product. That's a product that allows us to take a game that was originally written for Windows and bring it using our portability technology to the Mac. And we work very closely with a lot of the major game developers and publishers who are out there, so companies like Electronic Arts, Ubisoft, Activision, and so on. So some of the top titles we've done recently include The Sims 3, Dragon Age, Settlers, Prince of Persia, and the list goes on. What many of you probably don't know is that in addition to our work with the Mac and things like Cider, we're involved in quite a number of other portability-related activities. So we have some experience with both PlayStation and PlayStation Portable development. We recently shipped our first Wii title, which is Armin van Buuren in the Mix. And then beyond that, we have a pretty close relationship with the Kronos group. We're Kronos members, and we participate very actively and openly in both the OpenGL working group, the OpenGL ES working group, and then more recently working with you guys at Google in the Angle project, which aims to bring WebGL to PCs running DirectX. In addition to that, the product that the company originally started with was Cedega. It used to be called WineX, and that allows end users of Linux desktops to take their existing catalog of Windows titles and run them on Linux desktops. Swiss Shader, which is another product that we've worked with you guys on and shipped that with your O3D 3D technology. And then last but certainly not least is our Game Tree TV efforts. And Game Tree TV is a new system that we are deploying to cable operators and OEMs of connected TVs and set-top boxes for next-generation TV experience. We're bringing games to those platforms, both from the portability side of things as well as from the distribution and content side of things. So what I'm here to talk to you today about is cross-platform gaming and why it's important and why it's difficult, and what actually happens as developers look at the platforms that are available to them and make decisions about what platforms they should build their content on. One thing to understand about game development is that it can be a very expensive process. Whether you're one of the EAs of the world or Ubisoft or Activision's, the kind of projects that those companies get involved in can run up budgets into the range of $30–40 million for a top-end AAA title. It's very expensive. It's very important to those companies to make sure that they monetize that investment across as many platforms as possible. And right now, if you look at the ecosystem for game platforms, for systems that run games, it's actually broader than pretty much any other market in software. So you have the traditional consoles, devices you hook up to your TVs. You've got the 360, you've got the Wii, you've got the PS3. On the desktop side, you've got Windows Desktop, which certainly has the largest share of the market for games right now. You've also got the Mac and a small number of users on the Linux desktop side. Then you've got portable devices, whether they be smartphones or dedicated portable gaming consoles like Nintendo or Sony devices. Now we have tablets coming out. We've got iPad, we've got Android tablets coming out, Intel's got MeeGo tablets coming out, and the list goes on. And then lastly, as I was mentioning earlier, you have the connected TV platforms, which are really just going to be starting to ship at the end of this year and then into next year. So if you're a game developer, this is an enormous variety of platforms to choose from. And if you're making an investment, whether it's a $40 million investment of an EA or an Activision, or whether it's the investment of you deciding to quit your job because you love gaming and go and work with your buddies in your garage and pump out a game, that investment, that's your time, blood, sweat, and tears. That's a huge investment. So you need to make careful decisions about the platforms you target. So when you think about targeting multiple different platforms to try and maximize that investment, the question you might think of if you're not familiar with the area is, why is that so hard? C is pretty portable, or some people used to think that Java was really portable, but in fact it's not. There are a number of issues involved in dealing with these portability issues. So first and foremost is hardware. Different devices, it seems obvious, but different devices have different CPUs, different GPUs, different amounts of memory, different amounts of storage. So all of these things play in. Even if you're on the same CPU but you've got a different GPU, there can be significant issues. You've got different APIs you work with, whether those are on the graphics side with OpenGL or Direct3D, or whether they're on the system side. If you've got a code base, and some of the code bases that we've seen in our work, you run into the millions of lines of code. You have a code base like that, you've got touch points potentially all over the operating system that you've originally designed your code for. It's extremely difficult to build a project of that size and really have true platform independence. You guys, I think, are well aware of that with some of the projects that you work on, such as Chrome. I know it took a long time for Chrome to come up on platforms other than Windows. It's a very difficult problem, even for a company as big as Google, for a game developer who's working on smaller budgets, very tight timeframes. It can be even more so. And then last but certainly not least is the fact that you've got potentially completely different form factors. So on the one hand, if you're going from, say, a PC to a Mac, you've got the same CPU, you've got similar GPUs, you've got a similar form factor. But if you're originally developing for console and you want to move to PC or vice versa, there you've got control scheme differences, you've got all kinds of other differences. Weird things like the overscan in the TV, where you don't actually have as much resolution as you think you have, and which the HDTV vendors have mysteriously decided to continue on into the HD world, even though there's no real reason to have that when you've got an LCD panel. Different controllers, keyboard, mouse, handheld controllers. We have gesture controllers coming out, and the list goes on. So these are not simple problems. These are in many ways very, very complex problems, and they're ones that I've been spending the last 10 years working on, and they can be a lot of fun, even though they are sometimes very difficult and challenging. So some of the simple stuff, back to the hardware. You think about different CPUs and how do you typically cross that divide? Well, you obviously have to rebuild your code. Well, what's so hard about that? If you've looked at some of the code that comes out of a rushed 3 a.m. coding session from people who are trying to get a game out the door to meet a market deadline, that's not always the code that's the easiest to build on a different compiler. C++ especially, there are all kinds of differences between C++ compilers, how they deal with things like templates and many other things. And then just simply the actual build system. If you've got a million-line project which is composed of dozens of different components, some of which are from third-party vendors, some of which you don't even have source code for, that can be itself a very challenging problem. A problem that we have faced in this when we've been working with publishers has actually sometimes been they don't really have the code anymore. They don't really know what happened to it. They ship the product. That was a while ago. Maybe the publisher wants it on the other platform, but they never got the source code from the developer. In some cases, they have the source code, but they don't know what the correct version of it is. They want to ship the same version on Mac as on PC, and they invite us to come spelunking through their source code control system with them. These are if you're not thinking about cross-platform from the very beginning, these can be extremely difficult problems to deal with. Even if you are thinking them from the very beginning, they're still difficult, complex problems. GPU performance. This is one of the issues that, of course, happens when you want to try and go from a game that exists on a console or a PC down to a mobile device or a tablet. The GPU performance issues are very serious. If you build a game, if you do successfully go cross-platform, well, then you have, of course, now to multiply your test infrastructure. So if you've got 5 or 10 different varieties of PCs that you test on, and now you want to go to the Mac, well, you want to test on all the different GPUs that Apple ships. This problem, I think, in the mobile world was once and still today is far worse on the J2ME side, where the proliferation of different J2ME devices is such that it becomes a Herculean effort to try and test a game on 300 different devices. And then, once you actually are getting down to it, you say, yes, I want to bring my game, I'm going to invest the time and energy, we're going to make this happen. You can run into all kinds of very subtle differences. So what I'm showing here is a difference between OpenGL and Direct3D. So Direct3D, when sampling a texture, samples the texture from the corner as opposed to from the center. Actually, it might be the other way around. I honestly keep forgetting which way is which. So when that's happening, if you want to move that to OpenGL, you can either transform the texture offset that's being used, the UV coordinates at each vertex that you're using, or you can transform the position of those vertices. So unfortunately, those are mutually exclusive things that you can do on a global basis. So if you do what Transgaming does in terms of writing technology to take care of things for you, you have to choose one or the other. And if you've done the wrong thing, if you've done a different combination of things on the PC code to adjust for that offset, you can run into issues like this, where you see these very dark seams where textures were supposed to have been sampled together, but they weren't, because that half pixel offset turned into a half pixel on either side, and you have black in the middle. So those are sometimes very challenging problems to deal with. So on games, I sort of touched earlier on some of the unique factors of games. So one of these is that games are generally one-off projects. That's a little less so today than it was 5 years ago, but for the most part, when game developers work on a title, they work through the title, they finish the title, they ship the title, they move on to the next title. In many cases, at some of the larger publishers, the actual development teams for a given title are actually, the day of ship, they're literally split off into multiple separate teams to go work on the next project. So they may not, see each other again. So the code, it's the code that's used for the game is not a living, breathing system. It is a system that is by its nature transient. Those developers often work under very tight deadlines. Christmas, it doesn't change, so you can't push that off. You need to get your product out in time for Black Friday, and that's the way it is. So maybe you can push your manufacturer to manufacture a little later if you give them some more money, but ultimately you have to ship, especially if you're one of the larger scale developers. You have very tight deadlines to meet. Performance. Not only do you have to meet these tight deadlines, but your game has to run smoothly, and it has to run smoothly potentially across multiple different GPU and CPU incarnations. So especially on the PC side, when people are testing PC games, they have just a huge number of different varieties of systems to test against, and in some cases there are entire test labs that are separate from a regular QA system for a game developer that is used to do broad scale testing across different hardware to ensure that it meets minimum performance requirements. Because of all this, there's no premium on reusable code. Again, that's not always the case. That is something that is the case in some projects today, perhaps a little bit less so today, with things like MMOs and games that have longer tails. A lot of games have downloadable content, so they have a longer lifespan, and so that's perhaps a little bit less of an issue for those developers who are thinking about those things and thinking about their game in the long term. Asset costs. This is a huge one when game developers are dealing with resizing their content. So even something sometimes as simple as going from a widescreen aspect to also supporting a 4:3 aspect, that can require major changes in art because a developer has maybe set up a fixed 2D bitmaps for overlays and things like that. So art assets can be very expensive to re-engineer. You may sometimes need to start from scratch if you're going from a high-end platform to a lower-end platform. You need to have much lower detail models, which means different artwork has to be done to make those models look good for that platform. And then last but not least is the fact that there are licensing concerns, whether those licensing concerns are things such as third-party IP libraries that you've added into your system for physics or networking or something like that, or whether it's that the developer has licensed the game to the publisher for platform X, and in order for that publisher to publish on platform Y, they need to renegotiate their license with the developer. So these things have, even from the legal perspective, often extremely complex legal requirements. So traditionally, how do people solve this problem? Well, one way they solve the problem is simply to ignore it, release on a single platform, especially for independent developers who have fewer resources. They will pick a platform that they believe will serve them best, put the game out for that platform, see how it does. If it's successful, then they might look at bringing it to other platforms. There have been a few indie developers who've managed to do that. The 2D Boys have a game called World of Goo, which is awesome, and they've essentially done that. They had success in their initial releases, lots of fame and accolades, and then were able to start bringing the game to other platforms. But even when you're up in the AAA game space, this is not always something that is possible. Often a game will be released for a single platform, and they'll think, well, if we can't make both PS3 and 360 simultaneously, let's just go with one or the other, depending on various market factors, or potentially who's paying them for an exclusive license, and the other platform will sit by the wayside, and often any port that was contemplated will die on the vine. Other ways that this gets dealt with are after the fact ports. On the Mac market in particular, before Transgaming entered the market, this was the majority of ways that games came to the Mac. They would be generally licensed by a third-party publisher from the original publisher, and that third-party publisher would then pay for the development of the Mac version of the game and gain the value of publishing that game for the Mac. That's less the case now. That market has not been as active recently on the Mac side, and I'm skeptical that it will return in any platform as developers become more cognizant of cross-platform issues and look at ways that they can deal with cross-platform more generally and try and think about it earlier. I think that model is one that will remain by the wayside. Another thing that developers and publishers do is actually produce completely different games, but call it the same thing. This can be a fun one for reviewers. Well, I played game X on my PC and it was great, and then I played it on my Nintendo DS and it's a totally different game. Well, that shouldn't really be a surprise. You can't fit the same game on your DS. But this happens actually quite frequently, that there are entirely different code bases, entirely different teams, entirely different art, and the only thing that's the same is the name of the game. Some developers that do simultaneous cross-platform releases succeed at that with early planning. They think about it from the get-go. They know they want to target the set of platforms, and they plan for it either by building an internal engine that is capable of dealing with that, licensing a third-party engine that does that well, working with companies like Transgaming to make sure that when they release their game, it's going to be across multiple platforms, and so on. But that means that if you're thinking about that, you need to make that decision early rather than late. The later you go, the harder it is to do a cross-platform release, even if you're using very powerful cross-platform technology. And then last but not least, especially on the arcade side, games are frequently emulated, and generally this is applicable to older games where the CPU differences are such that this is something relatively easy to do. So at Transgaming, we've been doing this for a long time, and we approach this in a somewhat different manner. What we do is we cross the API and binary execution barrier. So typically when we take a game from Windows to Mac or Windows to Linux, we're actually taking that same original Windows executable and running it directly on the target platform. So our Cider product does this on the Mac side, our Sedega product does this on the Linux desktop side, and then the Gaintree TV portability engine, which is essentially very similar to both of those products, it's all the same code base, does this for connected TV devices going to OpenGLES. So this is very beneficial to developers because it means that if you're doing this, you have a single code base, you have a single build system. The actual binary that you've produced is the exact same binary on both platforms. This means that things like cross-platform network play become very easy. We had one game that we were dealing with where it was a real-time strategy game where the network protocol required literal bit-for-bit compatibility of floating point calculations that were happening. The only way to achieve that is to have the exact same instructions executing on both platforms. So there are many, many benefits to doing this, and of course, it can happen very, very quickly. So some of what we do in this, there's obviously a lot of complexity in there, but probably the most important part of that process is our support on the graphics side, where we take DirectX shaders and DirectX data structures, and at runtime run those through and translate to OpenGL. So as an example, an application might provide a shader in Microsoft's HLSL form to the Microsoft D3DX library. This is a utility library for Microsoft that does shader compilation from source code form to a binary representation. Our code would then come in and actually execute that. In this case, we don't have our own HLSL compiler. We rely on NVIDIA's CG compiler. We work with them to make CG more compatible with HLSL. So CG takes the shader, compiles it to Direct3D bytecode. It then passes it along, the game passes that shader along to Microsoft's D3D9 library. In this case, on a Linux machine, we would implement our lib D3D9 as a Linux shared library. That would take the command stream of the DirectX commands, send it down to our D3D to GL conversion layer, which we call D3D GL, and that would take those shaders and convert the bytecodes from Microsoft DirectX bytecodes to ARB assembly language or GLSL high-level shader language. That, of course, would then go to the platform OpenGL driver, which would then turn it into the shader representation required for the physical hardware, and the hardware goes and executes the shader. So that's sort of how that layer of things works. So the reality is that the difference between this and what actually happens, say, under Windows is in many ways not that different. There's still an HLSL to bytecode compiler that's happening at the D3DX level, and at the device driver level, there's still a layer that has to take that shader and turn it into a representation the hardware can execute. The work that we do, we try to have as minimal as possible. There's always some CPU time required for it, but in general, we try and push as much as possible to the GPU so that it's the GPU bottleneck that is the major focal point. That works well in some cases and less well in others, depending on the state of the drivers for the platform we're dealing with. So I see a couple people who've had a big lunch, and I figured now is a good time to have a bit of a demo to show you some cool stuff. What I'm going to show you is Chrome, actually. You think I'm kidding, but I'm not. What I've got here is EVE Online. EVE is a massive multiplayer game done by one of Transgaming's publishing partners, CCP, in Iceland, and that actually comes up properly. And EVE is a space combat game where players vie in the universe to take over as much property as possible and avoid having their cargoes pirated and so on and so forth. So this game is Windows executable. We work very closely with CCP to make sure that they stay within the boundaries of what our Cider engine is able to translate to Direct3D. And we take all the shader, all of this is being rendered using Direct3D, and we're translating it fully in real time into OpenGL, and there we go. So this is an example where there's a quite complex scene with something in the range of 70 different ships on screen at once, all running in real time with cool features like occlusions and so on when the sun is behind a ship, and various other things. Now, one thing that's important to understand is this is not emulation. We're not doing CPU level emulation. We're not doing instruction by instruction emulation. We've actually taken the Windows binary, loaded into memory, and it's executing as though it would under Windows. So the game is loaded the same address that it would be loaded under Windows. Anytime a call is made to Direct3D or any other Win32 API, that gets intercepted by our layer and executed. But some people might say, well, that's still emulation. You're emulating the API. Well, in fact, one of the things that we can do because of the way the technology works is we can actually integrate components that are completely native components. So what you're seeing here, once it comes up, here. So this is actually a browser that's built into the game. They did this because frequently users of the game want to compare prices of different objects and so on in the game. When we first, it's true that when we first ported EVE Online, we got a bug report saying, oh, copy and paste doesn't work. We're like, copy and paste? Why would you need to copy and paste from the game? And the answer came back, well, we need to take the tables from the marketplace and paste them into our Excel spreadsheet so we can analyze where we can buy the things most cheaply. So this is as part of supporting players doing things like that, CCP has used Chrome through an embeddable form called Osomium, and integrated that so you can not even leave the game and still have your web browser. But you'll notice that this has a Mac scroll bar. And in fact, what's happening here is that this is Win32 and Mac OS X code coexisting side by side in the same process, sharing an address space, calling back and forth using C library conventions. This kind of thing is a lot harder to do with C++, but it works quite well in C and allows for very tight integration between disparate platform interfaces, as you can see here. So getting back to our slides, in addition to our approach with this on the game technology side, we've also applied this approach in some of the work we've done with Google on the Angle project. So Angle aims to provide OpenGL ES interfaces on top of Direct3D in order to enable WebGL, which is a GL-based API, under Windows. In many cases, the Windows OpenGL drivers are insufficient to be able to properly handle more complex things that people want to build with WebGL. And so we worked with Henry and Vangelis and various other folks here at Google to come up with Angle. And my understanding is that it's shipping today last week in the Canary build. So anyone using WebGL under Chrome right now is using Angle, which is a very similar technique. We're taking OpenGL and translating the shaders into D3D shaders, translating the state, dealing with vertex buffers and so on to cross that platform divide. And then I mentioned earlier Swiss shader. That's another way that we cross platform divides, in that platforms that have lower spec GPUs or older GPUs where people still want to run GPU intensive software, we have Swiss shader, which actually completely executes the entire graphics pipeline in software. So rather than recompiling from OpenGL to Direct3D or the other way, we're actually taking Direct3D and taking the entire graphics pipeline and optimizing every draw call for all the shaders, all the rasterization into blocks of code that get dynamically generated at runtime and executed, and it runs really, really fast. So, current trends in the game market that affect this kind of these sorts of cross-platform things. Obviously, everyone has an app store of some kind or another now. Apple, of course, with the iPhone, and then various others being developed by platform vendors. One of the things that we think is really important to think about as the platform vendors to think about is the difference between a flea market where there's 300,000 different apps and you can't necessarily find what you're looking for, and more regulated markets. And I'll get back to that again in a little bit, but we think that's a fairly serious problem in that App Store ecosystem right now, where users have a lot of difficulty finding the things that they want. Web and online gaming is huge right now, both in terms of systems like Zynga's games on Facebook and elsewhere, as well as massive multiplayer games. So this is an important one for game developers, especially in emerging markets where piracy is a huge issue, where if you have to connect your game to a server somewhere in order to play, then you don't have to worry so much about the piracy issue. And certainly in those games, that's where some of the tendencies that I described earlier that the game developers can have to less quality code and less cross-platform are not as much of a problem, because those are by their nature living, breathing products. Another major trend to think about in gaming is core gaming versus casual gaming. The core gaming market is one which is currently very well served between the different consoles and high-end PCs and so on. But the markets that we see growing explosively right now are the lighter, simpler markets. I was at Intel's IDF earlier this week and was able to hear Will Wheaton speak about some of his experiences growing up in the 80s in gaming, and he had a really interesting story where he talked about how 10 years ago he and his wife brought out their old Atari 2600 console, and at first the kids were like, well, what's this? It doesn't look as good as our Sega. Why would we care? And they started playing some games and they got really into it, and he found that over the next month they played an awful lot of 2600, as simple as the graphics were. And part of that is about accessibility of games and making it easy for users to jump into a game and have fun, which is of course the whole point. And then lastly, because of market pressures and how expensive and risky it is to invest $10, $20, $40 million in a large-scale console gaming project, budgets are coming down. Developers are looking at the spaces where things like the iPhone and the iPad and tablet devices and simpler devices, simpler games, because it's less risky. You don't have to make a bet that your $20 million is going to pay off. Lots of developers are still doing the big bets, and that will obviously still continue. But there's quite a lot of interest now in lower budget games. And of course, as budgets go down, that makes it more difficult for developers to think about going cross-platform. Other major trends, of course, we have new platforms. I mentioned the tablets and mobile devices are obviously coming on hugely, and as a social gaming. The platform that we at Transgaming are most interested in right now is the connected TV platforms. These are both devices that are going to be offered by cable operators and TV vendors over the next 12 months and beyond, as well as devices offered by OEMs for over-the-top services bypassing the cable operator, or a buddy box beside the cable operator. So this is a market that we're quite heavily invested in. We work very closely with Intel on delivering games to this market through our Game Tree TV architecture. So when we think about platforms and as a platform provider, what do you want to do? How are you differentiating yourself against other platforms is an important question. How platform providers work with game developers and their overall outlook is obviously really critical as platforms proliferate. And there's a bit of a paradox for a platform provider, because fundamentally most platform providers want to have some kind of lock-in, whether that's an explicit lock-in through doing their own first-party titles. Some platform vendors, Nintendo's a great example of this. Nintendo makes a lot of money on Nintendo consoles. How much money everybody else makes on Nintendo consoles is not as clear. Or whether that's platform lock-in simply through market pressures. Apple has done a tremendous job with the iPhone and the market that they've created there that entices developers to focus on that market. It's going to be very interesting to see as more and more Android devices become more powerful, get more powerful GPUs, to see how that is going to turn out. And certainly, I think that the store side of things is going to play a very important role there. But the platform providers want to have some kind of lock-in, and yet, as budgets go down, it's very difficult to get that from developers because they have fewer resources with which to do that. We've described how complex this problem can be. So for a platform vendor, this is a very challenging thing to think about. In some cases, on the AAA consoles, Microsoft and Sony, have in the past literally paid millions of dollars to developers to have platform-exclusive content. So, what can platform providers do to improve the situation? Well, first and foremost, they can simplify developers' lives as much as possible. By using open standards, that enables developers to have APIs that work across platforms. So we Transgaming do that by making otherwise proprietary APIs able to run elsewhere. But as other platform vendors need to really think about their strategy for APIs and what APIs to use. So OpenGL is the obvious one on the graphics side. That's where an enormous amount of work in developing a game lies. On the audio side, OpenAL's out there. It's not necessarily as popular. There are a few other choices. Certainly, I would like to see more effort going into OpenAL by platform vendors to really make it a first-class audio API and solve that problem for developers. Everyone knows what they're doing when they're building audio. Another issue that we're seeing, especially as we move into the connected TV market, is input. So I'm not going to pull it out here, but on these various different TV devices, there are many different inputs available. So some developers are developing remotes that have motion sensitivity. Other developers have keyboards on the other side of a traditional remote that you flip around. Some developers have trackpads with keyboards. You press a button and the keys light up, so you can use it as a keyboard. Some developers are developing some really advanced, very cool gesture recognition technology where you simply move your hands and there's a Z camera that recognizes where you are and uses that input. But as a game developer, how do you deal with this problem of having these multiple different input devices? It's difficult enough going from PCs to consoles or back between keyboards and controllers, and how do you tell users about it? So this is a problem that we've been thinking about a lot. We have an API that we've been starting to get some feedback on from third-party developers, which we call stream input, where we're trying to say, if we can specify the semantics of what the application really wants. My game cares about go left, go right, go up, go down, shoot. And I specify that in some clear, concise way through an XML description. I can think about the actual physical input devices as being generic. So you might have a mouse, for example, and you take the input from the mouse and map that to the game. You might have a D-pad and map that to the game, and so on. So the stream input API, which as I said, we're hoping to start giving more public showings to soon once we've had some further feedback, aims to provide a general cross-platform system for handling input for games in a way that makes it easy for developers to solve this problem. Other things that platform providers can do to simplify things for developers is to avoid fragmentation. I mentioned earlier Day2Me, literally 300 different phone models that you would have to test. There are companies that devote enormous resources to outsource testing or very small scale development to deal with different screen sizes or what have you. This is an enormously difficult problem, and I think one that Google in particular needs to think about with respect to Android and as Android devices proliferate, how that's going to work with games and different screen sizes. Again, we talked about 4:3 versus widescreen. Dealing with that can be complicated. So as much as possible, the more you can avoid fragmentation of OS versions and all these other things, that's going to have a tremendous impact on game developers' abilities to deliver their games across multiple platforms. And then lastly, embracing third-party tool vendors. There's plenty of people out there who are working on good third-party game engines and other tools to make things go cross-platform. So the more that platform vendors look at those and try and make sure they're on their platform, that just makes it easier for the developer to choose the technology that they're familiar with, build the games the way they understand how and they're good at, and leverage work that others have done to go cross-platform. Then lastly, I mentioned earlier this issue of the App Store and the flea market versus a regulated market. There's a really interesting article in Scientific American from April 2004 entitled "The Tyranny of Choice." And essentially what it says is that having more choices is good, but only up to a point. And beyond a certain point, we as human beings tend to get overwhelmed by the choice. We have difficulty making the decision because there's so many choices. We find it very difficult to compare. And we think at Transgaming this is a serious problem right now on markets like the App Store. So one of the things that we've been looking at for our Game Tree TV service is to actually have more regulation in the market and make sure that what we're giving to consumers is something that is known, is high quality, that they can trust as being good. I think there's some really interesting ways that you can think about these problems. I suspect that you guys here probably think about those problems in terms of search, and I think that's interesting. But if you don't know what you want, how do you search for it? So I think it's really important for platform vendors to think about this as they look at store type architectures and so on. And that is the end of my presentation. So I'd be very happy to take questions if anybody has any. Yeah, go ahead.
In the phone space, do you think that the proliferation of smartphones with more or less identical touch screen sort of form factors makes the fragmentation problem go away in some ways? I mean, J2ME was just a total disaster. You had
Absolutely.
numeric keypads, you had phones with directional arrows, screen. I mean, it was really, really awful.
Yeah. Yeah, absolutely. So the question was, do I think, for those who may not be able to hear over the audio system, the question was whether I think that proliferation of phones that have very similar form factors helps there, and absolutely. If you're designing your game specifically around multi-touch input, then to the extent that the devices out there are multi-touch input, that's great for you as a game developer, and that's a good thing. So yes, absolutely. Henry.
I'm wondering how you think services like OnLive and Gaikai fit into.
So streaming, so that's a really interesting question. So the streaming services approach this problem by saying, well, we'll run the game back here in the data center and stream it to you. And it's definitely interesting. They're in trials now. I think actually OnLive is live here in the US. So there are several problems with that kind of approach. For one, a lot of what's going on there right now is aimed at that higher end market. That higher end market is already really well served. On the lower end market, you don't need something so complex to serve the connected TV type of games that we've been looking at. You don't need something like that, and it adds an enormous amount of capital expense to trying to get games out there. In the long term, how will it play? I don't know. We'll see what happens in the market. But certainly. So I've been here in San Francisco for the last week, and I have to say, my 3G service over the air has not been particularly good. Not too impressed compared to Canada, and which I have to tell you from the perspective of a Canadian. And dealing with service providers and bandwidth issues is kind of freaky. But yeah, it's I am somewhat skeptical that can serve as an effective means of dealing with the problem for from a scalability perspective, from a capital cost perspective, and then from just the bandwidth perspective. Doing that kind of streaming is bandwidth intensive, and will infrastructures, whether over the air or wired, be able to handle it well. We'll see.
I was wondering if you could talk a little bit more about the differences between a connected TV sort of deployments and consoles, because it seems like they're at first blush pretty similar, but in the connected TV thing, if you don't know what architectures are getting rolled out by the providers, the cable providers and other things like that, I'm not even sure how you target that market.
Right. So on the connected TV space, it's a very new space. Right now, we at Transgaming are working really closely with Intel. Intel has been pretty successful at signing up operators and signing up OEMs, in part because of the promise of gaming. Operators and OEMs see that as a great market for people who want to play games at home on their TV, who may not be as interested in a console type device, and they're very excited by that. Right now, as a game developer, this is a question for people. People don't know how to target those platforms. We at Transgaming believe that the best way to target that is through Game Tree TV, and by leveraging the technology that we've built and we've brought to the table to bring games over. In terms of non-Intel platforms, and who'll be successful there, a lot of those vendors are looking at solutions like Adobe Air and Flash and things like that, or even J2ME for delivering content on those devices. I think it's going to be interesting to see whether if WebGL takes off well on the desktop, whether that will play a significant role in that market going forward. I'm not sure that the devices that are the non-Intel devices will have the CPU and GPU capabilities to be able to do those well. So I think from a practical perspective, connected TV-based gaming is going to very much be Intel focused for the next, probably 18 to 24 months.
Yeah.
Go ahead.
Are you involved with Valve and their Steam platform?
So we have some of the games that we've brought to the Mac are on Steam. Yes, absolutely. Yeah, they're doing interesting stuff. We actually have our own portal as well for game distribution on the Mac side. Rather than Game Tree TV, it's called Game Tree Online. So a lot of our games go through that as opposed to through Steam. Anyone else? Go ahead.
You touched on this a little bit. What are your thoughts on the rise of ARM? And it seems like a lot of your technology is kind of screwed.
No, not at all. So again, from our perspective, any given technology is a bridge. We believe that we're in the business of building bridges between platforms. The form that bridge takes may change depending on the specific platform. So in the case of ARM, much of our technology could still be applicable on the Direct3D side, but people have to either recompile their code or deal with code translation technologies to go to ARM if they wanted to do something like that. In terms of we want to be in a position to help out the market. So I mean, if the market tomorrow all went ARM, then and if they all went ARM, then they'd probably all be going OpenGL and so on. There'd be other technologies that we would be able to bring to bear for that, whether it might be Swift shader integrated into devices in a way to provide GPU-like services on multi-core devices, what have you. So we see ourselves very much at the in that middleware bridging role to help, whether it's a platform provider or developer, bridge whatever gaps there are in bringing games to the platform, regardless of CPU. Go ahead.
So we see a native client port?
Native client port of
Your engine?
That's an interesting question. Certainly, it's something that we would like to talk more about. Native clients is an interesting technology. I still feel like I don't have a complete grasp of how it's going to play out in the marketplace and what the most important points are. One of the things about the Win32 porting technology that we have is that it relies fairly heavily on underlying Unix services, and the extent that native client has those or doesn't have those, would dictate whether that as an entire system could potentially run. But certainly, various different pieces of it could be useful for developers. And then I guess my understanding is that native client on the Windows side is going to be doing its OpenGL implementation on top of Angle. So in a sense, we're already involved.
Yes, you've got Windows on Mac and Windows on Linux. What other sort of platform pairs are you looking at?
Those are the one that we've focused on most for the last while. We have in the past explored consoles in a fair bit of detail. We'd actually brought some of our D3D porting technology over the PS2 way back in the day, and for a variety of reasons, in part due to some of those form factor issues and memory issues, it didn't actually make sense to deploy that because there were enough differences between the platforms to make that level of API compatibility moot. Right now, connected TV is the biggest thing we're looking at, and that's mostly Linux. Really, other platform pairings are going to depend on where the markets are and what's interesting, what's popular. Anyone else? Okay, well, thank you all very much. I really appreciate your time. This has been awesome for me. I appreciate the invitation to come down here. I hope that this was enjoyable for everyone and educational. Thanks.